Tonight, 3 stars you have already seen. Not a distant galaxy, not something that needs a telescope, not an object you have to take my word for. 3 stars that are, right now, either above your roof or about to be, that you have looked at without thinking about it your entire life, and that almost every human being who has ever lived has looked at too. A short, neat, unmistakable line of 3 bright stars, evenly spaced, evenly bright, tilted at a jaunty angle across the winter sky. Orion's belt. You know it even if you know nothing else in the night sky. It is the one pattern people can actually find. And here is what almost nobody realizes about it. That line is not real. Those 3 stars are not lined up in space, and they are not sitting at the same distance from you. They are separated by enormous gulfs, hundreds of light years in some cases, and the only reason they form a straight line at all is that you happen to be standing in the one place in the universe from which they appear to. Move a few hundred light years in any direction and the belt does not shift or stretch. It simply stops existing. Tonight, we are going to take the most familiar thing in the night sky and find out what is actually there. And it turns out to be 3 colossal, short-lived, doomed suns, one of which is among the most luminous objects our species has ever measured, all of them born together in a nursery that is still making stars tonight, and every one of them destined to explode. Now, let's begin. But before we go up, settle in. Let your shoulders come down, let the day finish loosening its grip, and let your breathing slow to whatever pace it prefers without you steering it. Perhaps you have already been lying here a while in the dark. Perhaps you are somewhere on a long night, waiting it out. Wherever you are, this is a good place to be, and there is nothing here you need to hold on to. Tonight is a slow look at something you have seen 1,000 times and never really examined, and if sleep arrives part-way through, that is exactly what it is for. Let us start with the thing itself, because it is worth appreciating just how unusual it is that we all know this particular pattern. There are 88 constellations in the modern sky, and almost nobody can find most of them. Ask an ordinary person to point out Lyra or Cassiopeia or Bootes, and you will usually get a polite shrug. The sky is genuinely hard to read, the patterns are mostly faint and arbitrary, and the names are the residue of thousands of years of accumulated storytelling rather than anything visually obvious. But Orion is different. Orion is the one that works. It is bright, it is compact, it is unmistakable, and at its center is the belt. 3 stars in a row that no other part of the sky imitates. Once you have seen it, you cannot lose it. Children spot it without being taught. It is, by a wide margin, the most recognized star pattern on Earth. And a large part of that is a geographical accident that is worth knowing because it explains why this particular pattern belongs to everybody. Orion sits almost exactly on the celestial equator, the projection of Earth's own equator onto the sky. And the consequence of sitting there is that Orion is visible from essentially the entire inhabited world, from the far north, from the deep south, from the tropics, from anywhere people have ever lived, Orion rises. That is not true of most of the sky. The Southern Cross has never been seen by most people in the Northern Hemisphere. The Big Dipper is invisible from much of the Southern Hemisphere, but the belt is everyone's, which is why when you look at the history of how human beings have interpreted that pattern, you find something remarkable. Almost every culture noticed those three stars independently, and almost every culture built something around them. In ancient Egypt, they were associated with Osiris, god of the afterlife. To the Maya, they marked the hearthstones of creation, with the fuzzy patch below the belt red as the smoke of the fire. Various Aboriginal Australian traditions see the three stars as young men, hunters or dancers, pursuing the sisters we call the Pleiades across the sky. In China, they formed part of a lunar mansion. In the Andes, in southern Africa, in Scandinavia, in the Pacific, the same three stars are picked out again and again and given names. I find that genuinely moving, and it is worth pausing on before we go anywhere near the astrophysics. The specific stories are all different and mutually unaware of each other, but the noticing is universal. Human beings scattered across every continent over tens of thousands of years, with no contact and no shared language, all looked up at the same 3 points of light and thought, that is a thing. That means something. Those go together. And that last part, that they go together, is the assumption we are going to spend tonight examining, because it is exactly half right in a way that is much more interesting than if it was simply wrong. Start with the naive reading, which is what nearly everyone carries around. Three stars in a line, evenly spaced, roughly equally bright. The natural assumption is that they are three similar objects sitting side by side at roughly the same distance, like three streetlights along a road. It is such a natural reading that it barely registers as an assumption at all. Now here are the actual numbers, and they are the first surprise of the night. The three stars of Orion's belt are not at the same distance from us. Measuring their distances precisely turns out to be surprisingly difficult, for reasons we will get to, and different methods give somewhat different answers, but the broad picture is not in doubt. They lie somewhere in the region of 1,000 to 1,400 light years away, and the differences between them are large, not a few percent. Hundreds of light years of difference between one belt star and another in some analyses. Think about what that means for the line. If the three of them are separated by hundreds of light years along your line of sight, then the neat, evenly spaced row you have been looking at your whole life is not a row. It is three objects at very different depths, which happen from this one particular vantage point to fall close together on the two-dimensional dome of the sky. The evenness of the spacing is a coincidence. The alignment is a coincidence. The pattern exists in your eye and not in space. Now, having taken the pattern apart, I want to put something back, because the full truth is subtler and considerably better than the tidy debunking. The three belt stars are not lined up in space, but they are related. They are, in the most literal sense, siblings. All three belong to a sprawling family of hot young stars that astronomers call the Orion Association, a loose grouping of massive stars strewn across that whole region of sky, all of them formed from the same enormous cloud of gas within the last few million years. The belt stars are among its most prominent members. They were born out of the same material in the same event at roughly the same time. They are not three unrelated strangers that happen to align. They are three children of one nursery who have since drifted apart. So the honest picture is this: the straight line is an illusion of perspective. The family is real. Those stars genuinely do go together, exactly as every ancient culture intuited, just not in the arrangement that made them think so. They are siblings standing at different depths in a very large room. And from the doorway where we happen to be standing, they line up. I love that as a resolution, because it means the ancient astronomers were not simply wrong. They saw three objects and concluded there was a relationship, and there is one. They just could not have known that the relationship is birth rather than proximity, and that the pattern that revealed it to them is an accident of where our solar system happens to sit. And there is a lovely difficulty hiding inside all of this, which is that measuring how far away these stars are turns out to be genuinely hard, and the reason is almost paradoxical. The standard method for measuring stellar distance is parallax, and it is beautifully simple. As Earth goes around the Sun, our viewpoint shifts by an enormous distance, about 186 million miles from one side of the orbit to the other. A nearby star seen from those two positions 6 months apart appears to shift very slightly against the more distant background, exactly as your thumb appears to jump when you look at it with one eye and then the other. Measure that shift and simple geometry gives you the distance. It is the only truly direct method we have, requiring no assumptions about the star itself. The problem is that the shift is tiny, and it gets tinier with distance. For anything more than a few hundred light years away, it becomes a fantastically small angle, and for most of astronomical history, it simply could not be measured for distant stars at all. That changed with the Gaia spacecraft, a European mission that spent years measuring the positions of well over 1 billion stars with a precision nobody had previously approached, and which has rewritten the distance scale of our galaxy. But Gaia has an unexpected weakness, and the belt stars run straight into it. Gaia was designed to measure enormous numbers of ordinary stars, and its detectors saturate on the very brightest objects, in the same way a photograph of a light bulb blows out to a featureless white blob. Alnilam, the middle star of the belt, is one of the brightest stars in the sky. It overwhelms the instrument. The most precise distance measuring machine ever built cannot get a reliable parallax for it, precisely because it is too bright. So astronomers went sideways, and the workaround is elegant. If the belt stars are members of a family, and the fainter members of that family are scattered all around them and are perfectly measurable, then measure the siblings instead. Take the parallaxes of the many faint young stars in the same association, average them, and you get the distance to the group, and therefore a far better estimate for the bright star you cannot measure directly. The brightest object in the neighborhood is located by triangulating from its dimmer relatives. There is a nice quiet lesson in that, and it recurs throughout astronomy. The most conspicuous thing is often the hardest to pin down. The stars that dominate the sky are frequently the ones whose properties are least certain, because everything about them is extreme, and our instruments are built for the ordinary. Meanwhile, the faint anonymous stars nobody has ever named are cooperative, well-behaved, and easy to measure, and they end up carrying the whole distance scale on their backs. Which is why the numbers you find for the belt stars vary from source to source, sometimes substantially. If you look up Alnitak, you may find 800 light-years in one place and 1300 in another. That is not carelessness. It is a genuinely difficult measurement made on objects that resist it, being steadily improved, and the honest position tonight is that the belt sits somewhere around 1100 to 1300 light-years away, with real uncertainty on each individual star and real differences between them. But hold on to the number in the round, because even the rough version is worth feeling properly. Somewhere in the region of 1200 light-years, that is the distance the light from those three stars has traveled to reach the back of your eye tonight. 1200 years. Let that sit for a moment, because it is one of those numbers that becomes real if you give it something human to lean against. The light arriving from the belt tonight left those stars around the year 800. When that light departed, Charlemagne was being crowned. The Vikings had not yet reached North America. The great cathedrals of Europe had not been imagined, let alone built. Every single thing you have ever heard of from the last 12 centuries, every war, every invention, every person in every history book happened while that light was in transit. And it has been arriving continuously the whole time. Every human being who has looked at Orion's belt across those 1200 years, in every culture we mentioned earlier, was catching photons that left before their civilization existed. The light you will see if you go outside tonight is not new, it is medieval. You are looking directly at the past with your naked eye from your doorstep, and the past is arriving at the rate of one night per night, forever. It is worth pausing on how astonishingly recent our ability to say any of this is, because for almost all of human history, the question of how far away the stars are was not merely unanswered. It was considered unanswerable. Think about the problem as it appeared to anyone before the 19th century. You have points of light on a black dome. You have no way to touch them, no way to triangulate against anything, and crucially, no way to tell a nearby faint star from a distant bright one, because those look identical. There is no depth information in the sky whatsoever. For thousands of years, the honest scientific position was that the stars might be attached to a physical sphere surrounding the world, and that position was not stupid. It was simply the reading that the available evidence supported. The idea that could break the problem was parallax, and it was understood in principle for a very long time before anyone could execute it. If Earth moves around the Sun, then nearby stars should shift against distant ones over the course of a year. That is straightforward geometry, and the ancient Greeks knew it. In fact, they used it as an argument against the Earth moving at all, because they looked for the shift, could not find it, and concluded reasonably that Earth must be stationary. The alternative explanation that the stars were simply so unimaginably far away that the shift was too small to detect was available to them and seemed absurd. It turned out to be correct, so the measurement became a kind of holy grail, and for 2 centuries after the telescope arrived, the best astronomers in Europe tried and failed. The angles involved are brutal. For even the nearest stars, the annual shift is under 1 second of arc, which is the width of a coin seen from several miles away. Every attempt failed, and several announced successes turned out to be instrumental error. It was finally done in 1838 by the German astronomer Friedrich Bessel, who chose his target cleverly. Rather than picking a bright star on the reasonable but unreliable assumption that bright means near, he picked a fairly dim one that was known to be moving unusually quickly across the sky, on the grounds that fast apparent motion is a better indicator of proximity. He measured its shift over months with painstaking care and got an answer: a little over 10 light years, the first real distance to another star ever in the history of our species. And notice how recent that is. Bessel published in 1838. Photography was being invented in the same decade. There were people alive then whose grandparents were alive when nobody on Earth knew how far away a single star was, which puts tonight's numbers in their proper light. The distance to Orion's belt is not ancient knowledge. It is not something the Greeks or the Egyptians or the Maya had access to, for all that they built calendars and monuments around those 3 stars. Every civilization that revered the belt did so without any idea whether it was a mile away or beyond counting. They knew the pattern intimately and knew nothing about the objects. We are the first generation of humans who can look up at that shape and know that the left one is 3 stars, that the middle one is 400,000 suns, and that the light is 1,200 years old. That knowledge is a handful of decades in its precise form, and less than 2 centuries in any form at all, against tens of thousands of years of people looking. I find that genuinely humbling rather than triumphant. We did not earn the view. We inherited a very long queue of people who looked at the same 3 stars, wondered, and died without knowing. And the only difference between them and us is that we happened to be born after the arithmetic was worked out. The looking is the same. Everyone who has ever stood outside on a cold night and picked out that line was doing exactly what you can do tonight. We just have the footnotes now. Now let us meet them individually, because we have been calling them the belt as though they were one object, and they are 3 entirely distinct and rather extraordinary suns. We will take them in the order they appear, left to right as seen from the northern hemisphere, which is the order they rise. Start with Alnilam, the easternmost, the one closest to the bright star Rigel's side of the sky. Its name, like all three, comes to us through Arabic from the astronomers who preserved and extended Greek astronomy through the medieval period, and it means the girdle. And the first thing to say about Alnilam is that it is not a star, it is three. What looks to your eye like a single point is a system of at least three stars bound together. The principal member is a blue supergiant, an enormous, ferociously hot star of the class astronomers call O-type, which is the hottest and most massive category of ordinary star there is. O-type stars are genuinely rare. Out of every few million stars in the galaxy, roughly one is an O star. They are so uncommon that if you added up all the O stars in the Milky Way, you would have a very small fraction of 1% of its population. And yet three of them happen to be sitting in a row in the most famous asterism in the sky, which tells you something about how our attention works. We notice the extraordinary and assume it is representative. Alnilam's primary is something in the region of 30 times the mass of our Sun, with a surface temperature around 30,000 degrees, which is roughly 5 times hotter than the surface of the Sun. And temperature matters enormously for how much light a star pours out, because the energy radiated rises with the fourth power of temperature. Make a star 5 times hotter, and size for size, it radiates something like 600 times as much. Combine that with being vastly larger, and the totals become difficult to hold in the head. Alnilam radiates on the order of 100,000 times the light of our Sun. And it is blue, genuinely blue, which is worth noticing next time you are out. Most stars, to the naked eye, look white. The color differences are subtle and easy to miss, but if you look at Orion carefully on a clear night away from lights and let your eye rest, you can sometimes catch that the belt stars have a cold bluish cast, and that up on Orion's shoulder there is a star with a distinctly warm, orange, almost ruddy tone. That is a real color difference, and you are seeing real physics with unaided eyes. Blue means hot and young and enormous and short-lived. Orange or red means cool, and in that particular case means dying. We will come back to the orange one. Next along, the middle star, Alnilam, the string of pearls. And this is the one I want to spend the most time on because it is, by a considerable margin, the most extraordinary object in the belt and quite possibly one of the most extraordinary objects visible to the naked human eye from anywhere on Earth. Alnilam is a blue supergiant of about 40 times the mass of the Sun. Its surface sits at something like 25,000 degrees, and its total light output is in the region of 375,000 times that of our Sun, with some estimates running higher still, above 400,000. I want to try to make that number mean something because it is easy to let a figure like that slide past. Take every photon our Sun emits in an entire year, all of it, the whole output of the star that powers every living thing on this planet and has done for 4 billion years. Alnilam emits that much light in roughly 90 seconds. Put it where our sun is and the Earth would not be a planet. It would be a memory. The oceans would be gone in moments, the crust would boil, and the atmosphere would be stripped away entirely. And now hold the distance against the brightness, because this is what makes Alnilam remarkable rather than merely large. It is roughly 1,200 light-years away. Most of the bright stars you can see are neighbors within a few tens or low hundreds of light-years. Alnilam is far outside that neighborhood, deep into the galaxy, and it is still one of the brightest stars in our sky. It is shouting loudly enough to be conspicuous from a distance at which almost everything else would be invisible. If Alnilam were as close to us as our nearest stellar neighbors, it would be brilliant enough to cast shadows at night and would be visible in broad daylight. It is also very young, and this is the fact that reframes everything else about it. Alnilam is about 4.5 million years old. Sit with that against our own sun's 4.5 billion. Alnilam is 1,000th of the age. In human terms, if our sun were a middle-aged adult of 45, Alnilam would be around 2 weeks old. It is a newborn. Everything about it, its size, its blue heat, its outrageous output, is the behavior of an infant star burning through its inheritance at a catastrophic rate. Because that is the trade, and it is the central fact of stellar life. Mass buys you brightness and costs you time. A star of 40 solar masses has 40 times the fuel of the sun, but it burns it so ferociously that it will exhaust the lot in a few million years, where the sun will last 10 billion. The most massive stars live the shortest lives by an enormous margin. They arrive, they blaze, they die, and the whole performance is over before anything slower has had time to notice. So Alnilam is not going to be there long. Astronomers expect that within roughly the next million years, it will swell into a red supergiant, and here is the detail I have been saving. When it does, it is expected to become brighter than Betelgeuse. That orange star on Orion's shoulder, the famous one, the one everybody watches for signs of explosion, will be outshone by the middle star of the belt. And then Alnilam will explode as a supernova, which means the neat middle jewel of the most familiar pattern in the sky is a doomed object. Not doomed in the loose sense that everything eventually ends. Doomed on a schedule, in a way we can calculate, and in cosmic terms, very soon. I should explain what is actually happening inside a star like Alnilam, because we have been describing the outside, the brightness and the color and the wind, and the reason for all of it lives in the core, and it is genuinely worth understanding. Every ordinary star is a balance between two things that want opposite outcomes. Gravity is trying to crush it. The star is enormously massive, and every part of it is pulling every other part inward, and left alone that would collapse the whole object catastrophically. What stops it is heat. In the core, the temperature and pressure are high enough to force hydrogen nuclei together into helium, and that fusion releases energy, and that energy pushes outward. A star is a controlled collapse, held open by its own furnace, and it stays exactly as large as the point where those two forces balance. Now make the star heavier and watch what happens. More mass means more gravity, which means the core is squeezed harder, which means it gets hotter, and the rate at which fusion proceeds is savagely sensitive to temperature. In massive stars, a different fusion process dominates, one that uses carbon and nitrogen and oxygen as catalysts to convert hydrogen to helium, and its rate scales with something close to the 17th power of temperature. 17th. Raise the core temperature by a modest fraction, and the energy output multiplies enormously, which produces the rule that governs everything about tonight. A star with 40 times the sun's mass does not shine 40 times as brightly. It shines hundreds of thousands of times as brightly. It has 40 times the fuel and burns it perhaps 100,000 times faster. And so its life is not longer than the sun's, but dramatically shorter. 10 billion years for our star, a few million for Alnilam. Everything else follows from that. The blue color follows because the enormous energy flow makes the surface ferociously hot. The colossal wind follows because the radiation streaming out is intense enough to physically lift the star's outer layers off. The rarity follows because such stars die so quickly that at any moment only a tiny number exist. And the explosive ending follows too, which is worth walking through because it is the most extraordinary sequence in nature. When a massive star exhausts the hydrogen in its core, it does not simply stop. The core contracts, heats further, and begins fusing helium into carbon. When the helium runs out, it contracts again and starts on carbon, then neon, then oxygen, then silicon. Each stage is faster than the last, dramatically so. Hydrogen burning lasts millions of years. Helium, hundreds of thousands. By the time the star reaches silicon burning, the whole stage lasts about a day. Read that again, because it is one of the great facts. A star that has existed for millions of years spends its final full stage of fusion in roughly 24 hours. And then it hits iron, and iron is the wall. Fusing anything up to iron releases energy. Fusing iron consumes it. So when the core becomes iron, the furnace that has been holding the star open against gravity simply switches off, and the balance we described at the start is broken instantly. The core collapses in on itself in a fraction of a second, falling inward at a substantial fraction of the speed of light, and the collapse only stops when the material reaches a density where it physically cannot compress further. At that point, the infalling outer layers slam into an incompressible core and rebound, and the resulting shockwave, assisted by an almost unimaginable flood of neutrinos released in the collapse, blows the entire outer star apart. That is a supernova. And what is left at the center is either a neutron star, an object with more mass than the sun compressed into the size of a city, or if the star was heavy enough, a black hole. So when we say the belt stars are doomed, that is the specific sequence they are queued up for. Alnilam has been running its hydrogen stage for 4.5 million years and is nearing the end of it. It will swell, redden, work its way down the chain of heavier fuels with each stage shorter than the last, spend a final day fusing silicon, and then collapse and detonate. And here is the part that connects it to you, which we will return to properly later. Every element heavier than iron in the universe, and a large share of the lighter ones, was made in stars, and much of it was made and scattered in exactly these events. The middle star of Orion's belt is currently manufacturing the material that will one day be somebody's planet. That is not poetry. That is the industrial process, running now 1,200 light years away, visible to your naked eye from your own garden. Before we leave Alnilam, one more thing about it, because a star like that does not simply sit there shining. It is actively coming apart, and we can measure the rate. Enormous hot stars produce something called a stellar wind, and calling it a wind understates it considerably. The radiation pouring off the surface is so intense that it physically pushes the outer layers of the star away, and the material streams outward continuously. Our sun does this too, gently, and that solar wind is what causes auroras and shapes comet tails. Alnilam's version is on a different scale entirely. Its wind blows outward at something like 1,000,000 miles per hour, and it sheds mass roughly 20 million times faster than the sun does. 20 million times. The star is evaporating in front of us, throwing its own substance into space at a rate that will meaningfully reduce its mass over its brief lifetime. And that material does not vanish. It spreads out into the surrounding region, enriching it, and it is part of why the whole area around the belt is filled with glowing gas, which we will come to shortly. The star is not just occupying its neighborhood, it is feeding it. Now the third star, Mintaka, the westernmost, the one that rises first and sets first, and the name simply means the belt. Mintaka is the faintest of the three to your eye, and it is also, in a sense, the most complicated. Like Alnitak, it is not one star but a system, and a rather busy one, with multiple components orbiting in an arrangement that has taken a great deal of careful work to untangle. The main pair orbit each other closely, whipping around in a matter of days, and there are further companions further out. What arrives at your eye as a single modest point of light is in fact several enormous stars circling one another. And Mintaka has one lovely property that you can use, which is that it sits almost exactly on the celestial equator. Almost exactly. Which means that Mintaka rises very nearly due east and sets very nearly due west from anywhere on Earth. If you are ever outside at night and genuinely disoriented, and Orion is up, Mintaka will tell you which way is east or west, depending on whether it is climbing or descending. A navigational instrument, free, permanently installed, and visible from every inhabited place on the planet. So there is the belt, properly introduced. 3 systems rather than 3 stars, something like a dozen individual suns if you count all the components. Every one of them vastly larger, hotter, and more luminous than our own star. All of them young enough that our sun predates them by a factor of 1,000. All of them destined to explode, and arranged in a line only from here. Which raises the obvious question, and it is the one I would want to ask at this point. What would it actually be like there? So let this be tonight's first long stillness. Come with me and stand somewhere inside the belt. Choose a world. There is no known planet around any of these stars, and we will come back to why that is probably not an accident, so this is imagination rather than reportage. But make it a bare rock, airless, a captured lump of stone in a wide orbit around Alnilam, and stand on it. The first thing is the light, and it is difficult to describe because nothing in your experience is like it. The star does not look like a sun. Even from a great distance, further out than Pluto is from us, Alnilam would be a searing blue-white point of such intensity that looking anywhere near it would be impossible. The light is not warm, it is not golden. Blue-white light at 25,000 degrees has a hard, clinical, merciless quality, and every shadow it casts is knife-edged and absolutely black, because there is no atmosphere to soften anything. And the light is not the dangerous part. A star that hot pours out a large fraction of its energy as ultraviolet, far beyond what your eye can see. Standing here unshielded, the visible glare would be the least of your problems. This is a place that sterilizes. The radiation environment around a young O-type star is one of the most hostile in the galaxy. And it is why the question of planets around such stars is a difficult one. The intense radiation tends to blow away the very disk of gas and dust that planets would need to form from, evaporating it before worlds can assemble. These stars may simply not permit planets, and if they do, the planets are unlikely to permit anything else. Now look away from the star, out at the rest of the sky, because this is the part that would genuinely take your breath. You are inside a stellar nursery, not near one, inside. The sky here is not the sparse scattering of distant points you know from Earth. It is crowded. Other enormous blue stars hang in the dark at distances of a few light years, close enough that several of them are far brighter than Venus ever gets in our sky, some bright enough to read by. Between and behind them, vast sheets and pillars of glowing gas, lit from within by all that ultraviolet light, spread across the whole sky in curtains of red and green, structures light years across that would be visible as shapes rather than as points. And it is a young sky, which means it is a changing one. Somewhere in this region, on timescales of hundreds of thousands of years rather than billions, stars are still condensing out of the gas. You are standing in a place where the process that made our sun is happening now, all around you, at scale. Then remember what it costs. Every one of those brilliant blue neighbors is burning through its life at the same catastrophic rate as the star you are orbiting. In a few million years, most of the bright things in this sky will have exploded. This entire spectacular arrangement, the crowded stars, the glowing curtains, all of it is a brief moment in a very long story, and it will not last long enough for anything living to evolve here and appreciate it. It is the most beautiful sky imaginable, and there is almost certainly nobody there to see it, which is, I think, the honest condition of most of the beautiful things in the universe, and not a sad one once you make peace with it. There is a question I have been circling and should answer directly because anyone paying attention will have arrived at it. If stars like these are so rare, why are three of them sitting together in the most obvious pattern in our sky? That seems like an extraordinary coincidence, and coincidences that large usually mean you have misunderstood something. The answer is a lovely piece of reasoning, and it explains a great deal about how the night sky is put together. Start with the rarity, which is real. Massive stars are genuinely uncommon. When a cloud of gas fragments and collapses into stars, it does not produce them in equal numbers at every size. It produces enormous quantities of small, dim ones and very few large, bright ones, and the imbalance is severe. For every star born at the top end of the mass range, there are many hundreds born small. Red dwarfs, the smallest and dimmest ordinary stars, make up something like 3/4 of everything in the galaxy. The monsters are a rounding error by count. But now add the second fact, which cancels the first in our perception. Brightness scales with mass far more steeply than rarity does. A star like Alnilam is 1 in millions by number and hundreds of thousands of times brighter than the Sun. So although there are vastly more small stars, the few giants dominate everything you can actually see. Work that through, and you get a conclusion that genuinely surprised me the first time I encountered it. Essentially, every star you can see with your naked eye is unusual. The night sky is not a fair sample of the galaxy. It is a highlight reel. Almost all of the several thousand stars visible to an unaided human eye are intrinsically far brighter than the Sun, many of them enormously so. And the ordinary population, the red dwarfs that constitute the actual bulk of the galaxy, is entirely invisible. Not one is bright enough to see from anywhere on Earth, ever. So when you look up, you are seeing a curated exhibition of the rarest and most extreme objects, selected automatically by the simple physics of brightness and distance, with the ordinary universe filtered out completely. The sky is a survivorship bias made of light, and that resolves the coincidence. The belt stars are not together because giants cluster, though there is a bit of that too. They are conspicuous because giants are the only things conspicuous at that distance. There are certainly thousands of ordinary stars scattered across that same patch of sky at every distance from a few dozen light years to the far side of the galaxy, and you cannot see a single one of them. The 3 you can see are the 3 loud enough to carry 1,200 light years. There is a genuine clustering effect on top of that, which is the association we discussed. Massive stars form in groups because it takes a large, dense cloud to make one, and such a cloud makes many stars at once. So giants do tend to be found near other giants, and the belt is a real example. But the reason those particular three dominate your view is mostly the filter, not the family. I find this reframes the whole experience of looking up, and it is worth carrying outside with you. The night sky feels like a survey of what is out there. It is nothing of the sort. It is a list of exceptions. Every point of light you can see is there because it is extreme enough to overcome distance, and the actual contents of the galaxy, the small, the cool, the numerous, the ordinary, are pressed invisibly into the black between them, which means the black is not empty and never was. It is where almost everything is. The stars are the anomalies, and the darkness between them is the norm, populated to the brim with objects too modest to announce themselves. Now, come back down to Earth and look at the belt again, because there is something hanging below it that you have almost certainly seen and probably never examined, and it is the most extraordinary object in this part of the sky. Beneath the three belt stars, if you look on a dark night, there is a smaller and fainter line of 3 points hanging downward, which the old star maps call Orion's sword. And the middle object in that sword is not quite a point. It is fuzzy. If your eyes are good and the sky is dark, you can see that it is not sharp the way a star is, that it has a soft, smudged quality, like a thumbprint on glass. Some people can see this immediately. Others need to know to look. But it is genuinely visible to the naked eye, and it is one of the very few objects outside our solar system that reveals itself as something other than a point without any equipment at all. That smudge is the Orion Nebula, and it is a place where stars are being made right now. It is roughly 1,300 light-years away, comparable to the belt, and it is enormous, some 24 light-years across. And it is the nearest region of massive star formation to Earth, which makes it, without exaggeration, one of the most studied objects in the entire sky. If you want to understand how stars are born, you need a nursery close enough to see into, and this is the one we have. What you are looking at is a cavity in a much larger cloud. The whole region behind and around it is dense cold gas and dust, mostly hydrogen, and somewhere inside it a batch of stars ignited a few 100,000 to 1,000,000 years ago. Those newborn stars, hot and violent in exactly the way the belt stars are, began pouring out ultraviolet light and stellar wind, and that radiation has excavated a hollow in the cloud. A blister opened up on the near side, and we happened to be positioned to look straight into the opening. So, the nebula is not really a cloud. It is a hole in a cloud, glowing because the gas is being lit from inside. And the glow itself is worth understanding because it is a genuinely different physical process from what makes a star shine. The ultraviolet light from the hot young stars is energetic enough to knock electrons clean off hydrogen atoms. When those electrons eventually find their way back and recombine, they release light at very specific wavelengths. And one of those, deep in the red, is what gives the great star-forming nebulae their characteristic color in photographs. The nebula is not reflecting starlight. It is fluorescing. It is doing, on a scale of dozens of light years, what a fluorescent tube does in a kitchen. At the heart of the cavity sits a tight little knot of stars called the trapezium, 4 bright ones obvious in a small telescope and a swarm of fainter ones behind them. And these are the engine. They are the newborns whose radiation carved the hollow and lights the whole display. They are so young that in stellar terms they have barely arrived. And when the Hubble telescope was pointed into that cavity, it found something that changed how we think about our own origins. Scattered across the nebula, silhouetted against the glowing gas, or glowing faintly themselves, are hundreds of small dark objects, each one a young star wrapped in a flattened disk of dust and gas. Astronomers call them proplyds, short for protoplanetary disks. They are solar systems in the act of forming, not metaphorically, physically. Each one is a star that has recently condensed, still surrounded by the leftover material from its formation, and within that material, dust grains are sticking together and beginning the long process that ends in planets. Which means that when you look at that fuzzy patch below the belt, you are looking at the process that made everything you have ever touched running right now in bulk, at a distance we can actually resolve. 4.5 billion years ago, our own sun was one of those. The Earth was a disk of dust around a young star in a crowded nursery very much like that one. The nebula is not just an object, it is a photograph of our own beginning, taken from outside at a distance of 1,300 light years and 4.5 billion years. And there is a harder edge to it, which is worth including because it is part of the truth of the place. Those proplyds are being destroyed even as they form. The same fierce ultraviolet light that makes the nebula glow is also evaporating the disks, boiling the material away from the smaller stars before it can finish assembling into planets. Astronomers can see the disks being stripped, some of them trailing away like comets pointed away from the trapezium. Being born in a bright nursery is dangerous. The massive stars that light the place also sterilize it, which raises a genuinely interesting question about us. Our own sun probably formed in a cluster like this, and there is real evidence for it, including certain isotopes in ancient meteorites that appear to require a nearby supernova at the time of our formation. So we were in the crowd once, and then at some point our sun drifted away from its siblings, out of the dangerous bright nursery into the quiet suburbs where nothing has disturbed us for billions of years, which turned out to be exactly what was required for anything slow and complicated to happen here. We got out. That is a large part of why you exist. Whatever family the sun was born into has long since scattered, and those sibling stars are out there somewhere in the galaxy, unidentified, and we will almost certainly never know which ones they are. Now let us pull back, because we have been looking at individual objects and there is a much larger structure containing all of them. And once you see it, the whole region reorganizes itself in your mind. Everything we have discussed tonight The three belt stars, the nebula in the sword, the horsehead, the flame, and a great many objects we have not mentioned are not separate things that happen to lie in the same direction. They are components of a single, enormous complex, one of the largest structures in our part of the galaxy, and astronomers refer to it as the Orion Molecular Cloud Complex. It is a region of gas and dust hundreds of light years across, containing something on the order of hundreds of thousands of times the mass of our Sun in raw material. Most of it is invisible. Cold molecular hydrogen does not glow, so the bulk of the complex shows up only in radio and infrared observations, or as darkness blocking the light of things behind it. What you see with your eyes, the bright nebula, the shining stars, is the small illuminated fraction. It is a lit doorway in an enormous dark building. And that complex is the thing that made everything in this part of the sky. The belt stars condensed out of it. The trapezium stars condensed out of it. The stars currently forming in the proplyds are condensing out of it right now. It has been producing stars in waves for something like 10 or 20 million years, and different regions of it are at different stages, which is exactly why the area is so scientifically valuable. You can look at one complex and see the whole process at once, from cold, untouched gas, through actively collapsing cores, through newborn stars still wrapped in disks, through blazing young giants like the belt, to stars old enough to have already exploded, because some of them have. And the evidence is written across the sky in a shape most people have never noticed. Wrapped around a large part of the constellation is an enormous faint arc of glowing gas called Barnard's Loop. It is far too faint for the naked eye, but long exposure photographs of Orion show it clearly. A great red semicircle curving around the belt, and the nebula, spanning many degrees of sky, hundreds of light years across in reality. And it appears to be a shell, a bubble blown outward into the surrounding gas. The leading explanation is that it was carved by the combined stellar winds of the massive stars in the region, and most likely by supernovae. Stars in this complex have already lived and died some millions of years ago, and their explosions pushed the surrounding material outward into an expanding shell that we now see edge on as a ring. Which means the region is not just a nursery. It is a nursery that has already buried some of its children, and their graves are the structure of the place. And that process is not merely destructive, which is the part that turns the whole picture around. When a massive star explodes, the shockwave rolling outward through the surrounding cloud compresses the gas it passes through. Compressed gas is gas that is more likely to collapse under its own weight. So the death of one massive star can directly trigger the birth of the next generation in a wave that propagates outward through the cloud. There is real evidence for this in Orion. The different subgroups of young stars in the complex have measurably different ages, and they are arranged in a rough sequence, consistent with star formation having swept through the region in stages rather than happening everywhere at once. The oldest group, then a younger one, then the belts group, then the very young stars around the nebula, which are still emerging now. So, what you are looking at when you look at Orion is not a static picture and not a single event. It is a chain reaction in progress, a vast cloud in which massive stars ignite, live briefly, explode, and in exploding, compress the gas next door into forming the next set, which will do the same. The bright things you can see are the current link. The dark gas is the fuel for the next one. Barnard's loop is the scar of the last one. And it will keep going until the cloud is used up or dispersed, which will take some tens of millions of years, and then the whole complex will disband, and the stars it made will drift apart into the general population of the galaxy, and there will be no Orion at all, just a scattering of unrelated suns in various directions with no memory of having been born together. Exactly, in other words, as happened to our own sun, which had a cloud and siblings and a nursery and a wave of star formation and lost all of it 4.5 billion years ago and has been drifting alone ever since. Orion is what our neighborhood looked like before we were a planet. We are looking from a comfortable distance at our own childhood photograph. There is a genuine historical puzzle attached to that fuzzy patch, and it is one of my favorite small mysteries in the history of observation. The Orion Nebula is visible to the naked eye. We have established that. It is not difficult. It does not require exceptional vision, and it sits directly below the most recognized asterism in the sky, in a constellation that every literate civilization catalogued in detail. Anyone who looked carefully at Orion's sword on a dark night should have been able to notice that the middle object is not a point, and yet the great star catalogues of antiquity do not appear to record it. Ptolemy, working in the 2nd century, compiled a catalogue of over 1,000 stars that remained the standard reference for well over a millennium, and he did note certain objects as nebulous or cloudy where he saw them. The Orion Nebula does not appear in that list, nor does it turn up clearly in the medieval Islamic catalogues that corrected and extended Ptolemy, despite those astronomers being extremely careful observers who added objects Ptolemy had missed. The first solid recorded observation of it as a distinct nebulous object comes in 1610 from a French observer using one of the very first telescopes, and it was described in more detail over the following decades as instruments improved. So the question is obvious. How does a naked eye object in the most examined constellation in the sky escape the notice of every professional sky cataloguer for 2,000 years? Nobody knows for certain, and there are several possibilities, all of them interesting. One is simply that it was seen and not recorded, because a small fuzzy patch did not fit the categories the catalogues were built around. Those catalogues existed to record positions of point sources for calendrical and astrological purposes, and a smudge is not a point, and may have been regarded as an atmospheric artifact or simply as not the kind of thing being catalogued. A second possibility, which is more interesting, is that it genuinely was less noticeable then. The nebula is lit by young stars, and the stars and the gas are both in motion, and the geometry of the illuminated cavity we look into is not fixed. It is at least conceivable that the object has brightened over historical time as the excavation has proceeded, though this is speculative and difficult to test. And a third possibility is the plainest and probably the largest contributor, which is that people record what their framework has room for. The medieval and classical sky was a sphere of fixed lights. Fuzzy things were a category error. There was no theory that predicted diffuse objects between the stars, no reason to expect them, and therefore very little reason to write one down if you happen to catch it, which is worth sitting with, because it is not a story about ancient people being unobservant. They were spectacularly observant. It is a story about how much of seeing is knowing what to look for. The nebula was arriving at every eye for the whole of that period exactly as brightly as it arrives now, and the information was simply not being caught because there was no net shaped like it. And I would gently suggest that the same is true of us in ways we cannot identify. There will be things in plain sight tonight arriving at our instruments that we are not recording because our categories have no slot for them, and some future generation will find it strange that we missed something so obvious. Meanwhile, notice who did apparently catch it. The Maya tradition that read the smoke of the first fire in that region of sky was, on the face of it, noticing exactly the thing that Ptolemy's catalogue does not contain. Different framework, different net, different catch. They had no telescopes and no theory of star formation, and they built a story around the one genuinely diffuse, naked eye object in the region, which happens to be the nearest place in the galaxy where stars are being born. They had no way of knowing they were right about it being a place where things are made, but they looked at the smudge and decided it mattered, which is more than the official record managed for 2,000 years. There is more hiding around the belt, and some of it is famous in a way that most people do not connect to the 3 stars they can actually see. Right beside Alnitak, close enough that the star's glare makes it difficult to photograph well, sit 2 of the most reproduced objects in astronomy. One is the Flame Nebula, a bright patch of glowing gas divided by a dark lane of dust that gives it the look of a burning log seen from the side. The other, a little further out, is the Horsehead. You know the Horsehead even if you did not know where it lives. It is the dark silhouette shaped unmistakably like a chestnut or a horse's head and neck rearing out of a wall of red glowing gas. It is on posters and album covers and textbook jackets. And here is the connection that surprises people. That object is essentially adjacent to the left-hand star of Orion's belt. When you look at Alnitak with your naked eye tonight, the Horsehead is right there, a fraction of a degree away, entirely invisible to you. And what it actually is deserves saying plainly because the popular image gets it slightly wrong. The Horsehead is not glowing. It is not made of anything special. It is a lump of cold, dark dust and gas, no more remarkable in itself than the material anywhere else in the cloud, and it appears to us only because it happens to sit in front of a bright, glowing background. It is a shadow, a cloud silhouetted against a lit wall. If you removed the glowing gas behind it, the Horsehead would simply vanish from view, not because it had gone anywhere, but because there would be nothing left to see it against. And the shape, of course, is meaningless. It is a lump. From a different angle, it would look like nothing in particular, and a few tens of thousands of years from now, as the gas continues to move and be eroded by the radiation from the belt stars, it will not look like a horse anymore. We are looking at a temporary accident of contour from one specific direction during one brief window, and our pattern-hungry brains have made a horse out of it, exactly as they made a belt out of 3 unrelated distances. That is twice now in one small patch of sky. The belt is a line only from here. The horse head is a horse only from here, and only for now. We are extraordinarily good at seeing figures, and the sky is extraordinarily good at supplying coincidences for us to see them in. Now let us go up to Orion's shoulder, to the orange one, because it is the counterweight to everything we have said about the belt. Betelgeuse, even the name is famous. It is the bright star at the upper left of Orion as seen from the northern hemisphere, and it is the one star in the constellation whose color is obvious to almost anybody. Where the belt stars are cold blue-white, Betelgeuse is a warm, ruddy orange, and once you have noticed it, you cannot stop noticing it. That color is telling you something important. Betelgeuse is a red supergiant, which means it is at the opposite end of the story from the belt stars. It began as a massive, hot, blue star, quite similar to them some millions of years ago. It has now exhausted the hydrogen in its core, and in response, it has swollen enormously and its surface has cooled. The size is difficult to convey. If you placed Betelgeuse where our Sun is, its surface would extend out past the orbit of Mars, possibly further. Earth would be inside the star, and it is much closer than the belt, somewhere in the region of 700 light-years, which makes the comparison instructive. Betelgeuse is nearer to us than the belt stars and appears comparably bright, which tells you immediately that it is intrinsically less luminous than Alnilam. The middle belt star is further away and still holding its own. That is the scale of what Alnilam is doing. Betelgeuse is also dying, and unlike almost anything else in the sky, it did something in living memory that made headlines. Beginning in October of 2019 and running into early 2020, Betelgeuse dimmed. Not subtly. It lost roughly 2/3 of its visible brightness, dropping to a level not recorded in the modern era. And it did it in a matter of months. And it was obvious to the naked eye. Anyone who knew Orion could look up and see that the shoulder had gone wrong. It is genuinely rare for a famous star to visibly change on human timescales, and inevitably a great many people concluded that the explosion was imminent. It was not. By April of 2020, the star had returned to normal brightness, and the investigation that followed produced an answer that is more interesting than an explosion would have been. What happened, according to the work published afterward, is that a huge upwelling of hot material rose from inside the star and was ejected from the surface, moving outward at something like 200,000 miles per hour. As that material traveled out into the star's cooler outer atmosphere, it cooled further, and it condensed into dust. A cloud of freshly made dust formed in front of the star from the star's own substance and partially hid it from us. Betelgeuse threw a piece of itself into space and then stood behind it. I find that a wonderful thing to have watched happen. We were not observing a death. We were observing an enormous star belching out a section of its own atmosphere, watching that material become dust and watching the dust drift into the line of sight. And we caught the whole sequence in a star 700 light-years away, using telescopes that could resolve the surface well enough to see which part of it had darkened. Betelgeuse will explode. That part is certain. It is at the end of its life by any reasonable measure. But the time scale is the sort that defeats intuition, because on stellar terms the end of its life could mean tonight or could mean 100,000 years from now. And there is no way to narrow it further. It might already have happened. The light simply has not arrived. And now the rest of the figure, because we have concentrated on 3 stars in a row, and Orion has more to say. Diagonally opposite Betelgeuse at the lower right of the figure as seen from the north is Rigel, and it is worth knowing that Rigel, not Betelgeuse, is usually the brightest star in the constellation. It is a blue supergiant, like the belt stars, and an extremely luminous one in the region of 100,000 times the Sun. It sits perhaps 800 and something light years away, and it marks the hunter's foot. So look at what the constellation actually consists of, laid out honestly. Betelgeuse at roughly 700 light years, Rigel at something over 800, the belt at 11 or 1200, the nebula at around 1300, Bellatrix, the other shoulder, at around 250, far closer than any of them. Nothing in Orion is at the same distance as anything else in Orion. The nearest bright member and the furthest are separated by something like 1,000 light years, which is comparable to the distance to the furthest one. The figure has enormous depth, and every bit of that depth is invisible to you, flattened onto the dome of the sky by the simple fact that your 2 eyes are far too close together to give you any stereo information at these ranges. And that is true of every constellation without exception. They are all like this. The Big Dipper, Cassiopeia, the Southern Cross, all of them are collections of objects at wildly different distances, projected onto a surface with the arrangement determined entirely by where our solar system happens to be sitting during the brief period we have been looking. The constellations, in other words, are not features of the universe. They are features of our address. There is one exception in Orion worth mentioning, because it is a real relationship rather than an apparent one. Several of the bright stars in the constellation genuinely are members of that same great association we have been discussing, born from the same complex. So there is a real family here, and the figure is not entirely a coincidence. But even the genuine family members are strewn across hundreds of light years of depth, and the specific arrangement into a man with a belt and a sword requires our particular viewpoint and would look like nothing at all from anywhere else, which raises a question I find lovely to sit with. What does our sun look like from there? If you were on a world orbiting one of the belt stars and you looked back toward us, our sun would be invisible, completely. At 1200 light-years, a star like ours is far too faint to see with any unaided eye, and it would take a decent telescope to detect at all. Our star is not a landmark from out there. It is not part of anybody's constellation. There is no pattern in that sky that includes us because we are simply not bright enough to participate, and that asymmetry seems worth naming. We look up at the belt and see three of the most conspicuous objects in our sky, which have anchored our myths and our navigation for as long as we have existed, and from their side, we are nothing, not dim, not obscure, absent. There is no possible arrangement of imagined observers up there for whom our sun is a feature of the night. That is not a sad fact, or at least I do not read it as one. It is a fact about brightness and distance and nothing else, but it does put a certain perspective on the relationship. Orion has meant something to every human culture in history. Every one of those cultures was looking at objects that could not, even in principle, have looked back. There is one more thing about the figure I want to leave you with, and it is small and practical and I think rather charming. Orion is the best signpost in the sky, and once you can find the belt, you can find a great deal else, because the belt points at things. Extend the line of the three belt stars downward and to the left in the northern view, and it runs almost exactly to Sirius, the brightest star in the entire night sky. Extend the same line the other way, up and to the right, and it takes you to Aldebaran, the orange eye of Taurus, and beyond that, to the little misty clump of the Pleiades. Three of the most famous objects in the sky, all locatable from the one pattern that everybody can already find. So, the belt is not only worth looking at for itself, it is the key to the whole winter sky, and it always has been, and every culture that used it for navigation had worked that out long before anybody knew what a light year was. There is a detail about the belt that most people in one half of the world have never encountered, and I want to include it because it is a small demonstration of everything we have been saying about viewpoint. Orion is upside down in the southern hemisphere. If you have only ever seen the constellation from the north, the picture in your head is fixed. Betelgeuse is the upper left shoulder, Rigel is the lower right foot, the belt slants across the middle, and the sword hangs downward beneath it. That is Orion. That is what he looks like. Now go to Australia or South Africa or Chile and look up on a summer evening. Everything is inverted. Rigel is at the top. Betelgeuse is at the bottom. The sword, from the northern point of view, hangs upward, and because of that, the southern half of the world does not generally see a hunter at all. In Australia and New Zealand, the belt and the sword together are widely known as the saucepan, with the three belt stars forming the base of the pan and the sword stars forming the handle sticking up out of it. Ask an Australian to find Orion, and a fair number will find the saucepan instead, and it is genuinely the more natural reading from down there because the figure of a man is upside down and the pan is the right way up. Nothing has changed in space. The photons are identical. The only difference is that observers in the southern hemisphere are standing on the other side of a ball and are therefore, relative to the northern observer, upside down themselves, and so the sky is rotated, which makes the point of tonight rather neatly at a scale you can actually get to. We have been saying that the belt is a line only from our particular position, and that a few hundred light years of movement would destroy the pattern entirely. Here is a version of the same principle that requires no light years at all. Move a few thousand miles, which people do routinely on aeroplanes, and the same three stars produce a different object. A hunter becomes a cooking pot. The figure was never in the sky. It was in the relationship between the sky and where the observer's feet happened to be planted, and that generalizes further than the belt. The whole northern tradition of constellations, the one that produced the official list of 88 and the names in every textbook, is a northern hemisphere inheritance, mostly Greek by way of Mesopotamia, and it describes a sky as seen from around 30 or 40 degrees north latitude. The southern sky, which those cultures could not see, got named much later and much less romantically, largely by European navigators in the age of sail, which is why it contains constellations called things like the air pump, the chisel, the microscope, and the telescope. The northern sky has heroes and monsters. The southern sky has laboratory equipment, because the northern sky was named by people telling stories, and the southern by people taking inventory. I find that a genuinely funny piece of history, and also a useful reminder. The sky is not annotated. Every name on it, every figure, every line drawn between stars on every chart, was put there by somebody, from somewhere, at some point, for their own reasons. There is no correct set. The stars are simply there in their positions, and everything else is us, which is worth holding as we come to the end, because it cuts both ways. It would be easy to take tonight as a debunking to conclude that the belt is a trick of perspective, and the constellation is arbitrary, and therefore the whole thing is somehow less than we thought. I would put it the other way round. The line is not in space, and it is genuinely in your experience, and your experience is a real thing that happens in a real universe. Every human being who has stood outside and felt that those three stars belong together was having an accurate experience of an actual pattern of light arriving at an actual eye. The pattern is not a mistake. It is simply local and temporary, and ours, which is exactly the same as almost everything else people care about. So let us ask the obvious question, because it is the one everybody arrives at eventually. What happens to us when one of them goes? The short answer is that it would be the most spectacular thing any living human has ever seen in the sky, and it would be completely harmless. Start with the harmless part, because that is the one people worry about, and it is worth settling. A supernova is a genuinely dangerous event, and if one occurred close enough, the radiation could strip a meaningful amount of ozone from Earth's atmosphere and cause real ecological damage. The estimates for how close is too close vary, but the figures generally discussed are in the region of 30 to 50 light-years, with some analyses stretching to 100 for the most energetic events. Inside that radius, you have a problem. Outside it, you have a light show. Betelgeuse is around 700 light-years away. The belt stars are perhaps 1200. Both are comfortably, enormously outside any plausible danger radius by a factor of 10 or more. Whatever happens up there, nothing happens down here. The ozone layer is fine, the oceans are fine, you are fine. Now the spectacular part. When a massive star explodes, for a period of weeks it can shine with the light of billions of ordinary stars, briefly outshining the entire galaxy it sits in. At a distance of several hundred to 1,000 light-years, that produces something our species has some historical experience of, because it has happened before, within recorded history. In the year 1054, a star exploded in the constellation Taurus, and Chinese astronomers recorded a guest star that appeared where nothing had been. Their records describe it as visible in broad daylight for over 3 weeks and visible at night for well over a year before it faded. Japanese and Arab observers noted it too. What they were watching is now the Crab Nebula, the expanding wreckage of that explosion, and it was around 6,000 light-years away. 6,000. So scale that down. A supernova at 700 or 1,200 light-years, several times closer than the one in 1054, would be dramatically brighter than that. The consensus expectation for something like Betelgeuse exploding is that it would reach roughly the brightness of a half-moon concentrated into a single point, bright enough to read a book by, bright enough to cast a sharp shadow on the ground at midnight from one star, easily visible in full daylight, sitting there in the blue sky next to the sun. And it would stay like that for weeks, then slowly fade over months, and eventually, after a year or two, disappear. And then Orion would be missing a shoulder, permanently. Every star map ever printed would be out of date. Every culture's version of that constellation would need rewriting, and whatever survives up there would be a slowly expanding cloud of debris visible in telescopes for thousands of years afterward, doing what the Crab Nebula is doing now. Sit with the strangeness of a thing like that happening in an ordinary week. Somebody would notice first, probably an amateur astronomer, and within hours it would be the only story anywhere on Earth. Everyone alive would go outside and look at the same point in the sky. And then it would be there every night for a year, gradually becoming ordinary, and then it would fade, and then the sky would simply be different forever. The odds of it happening in your lifetime are low, but they are not zero, and the honest position is that nobody can rule it out for tonight. There is a deeper point buried in the timing, and it is the one I actually want you to keep. When Betelgeuse explodes, or when Alnilam does, the event will not be happening when we see it. Betelgeuse is 700 light-years away, so the explosion we eventually witness will have occurred 7 centuries before we find out. The star that lit up medieval skies, that Galileo drew, that has been the shoulder of the hunter through every human generation, might have ceased to exist during the reign of the Tudors, and we would have no way of knowing. The news is in transit. It is somewhere out there tonight, crossing the emptiness at the speed of light, and it will arrive when it arrives, which means the sky is not a live feed. It is a mailbox, and every point of light in it is a letter that was posted at a different time. Betelgeuse posted 7 centuries ago. The belt stars posted 12. The Orion Nebula posted 13. When you look at Orion, you are not seeing a scene. You are seeing a composite assembled out of moments that never coexisted, arranged into a figure by the accident of your position, and the figure is not there, and the moments are not simultaneous, and the whole thing is nonetheless completely real and hanging over your house tonight. I think that is the single strangest fact about the night sky, and the one that gets said least often. There is no such thing as the sky right now. There is only the sky as it is arriving. Let this be tonight's second stillness then, and let it be the strangest one, because I want to take you to a night that has not happened yet. It is some evening in the future. Nobody knows which one. It could be 1,000 years from now. It could be next spring. The light has already been traveling for 12 centuries, and it arrives whenever it arrives. Picture an ordinary evening. Whatever an ordinary evening looks like by then, someone steps outside for the usual reasons. People step outside at night and looks up, half attending, and stops. There is a new star in Orion. It is in the belt where the middle one was, and it is not the middle one anymore. It is far too bright for that. It is brighter than Venus has ever been, brighter than anything in the sky except the moon. A single hard point of white light so intense that it is difficult to look at directly, and it is casting a shadow, an actual shadow, sharp-edged from a star on the ground at midnight. The person outside will not need to be told that something has happened. Nobody will. Whatever the state of astronomical literacy at the time, a sky that has been stable through all of human history has visibly changed, and every single person who goes outside that night will see it. Within hours, it will be the only subject anywhere, and there will be a peculiar quality to the conversation because everyone will understand very quickly that the event is not happening. It happened 1,200 years ago. While the light was crossing, an enormous star came to the end of a sequence of fusion stages, spent one final day burning silicon, and collapsed in a fraction of a second, and the wave from that has been traveling ever since and arrived tonight, unannounced, during someone's ordinary evening. For weeks, it will hang there in daylight, a white point in a blue sky, which is a thing almost no human being has ever seen. At night, it will be the dominant object after the moon, and it will not twinkle much because it is so bright, and it will stay in exactly the same place because it is a star, and the entire strangeness of it will come from the fact that the sky is not supposed to do this. And then, over months, it will fade. Slowly at first, then unmistakably. It will drop below Venus. It will drop back among the ordinary bright stars, and at some point, maybe a year or two later, It will stop being visible to the naked eye at all, and Orion will have 2 stars in its belt. That is the part I find hardest to imagine, and the part that would matter most, not the spectacle, the aftermath. Because the belt has been 3 stars for the entire duration of the human species. It is 3 stars on every star chart ever drawn, in every myth, in every navigational tradition, in the sky of every person who has ever lived. And then it will be 2 forever. And every subsequent human being will grow up with a 2-star belt and will have to be told that it used to be 3, the way we are told about animals that used to exist. The constellation will get renamed or reinterpreted, because that is what people do. Some new story will grow around the gap, and within a few generations the 3-star belt will be a historical fact rather than a memory, something you learn about rather than something you remember. And eventually the only people who find it strange will be the ones who read about it. Meanwhile, where the star was, there will be an expanding cloud of debris, invisible to the eye, growing slowly outward across centuries, carrying the manufactured elements of a 40 solar mass star into the surrounding gas. And that gas will be compressed by the shock wave, and somewhere in it, in a few million years, new stars will condense, enriched by the wreckage, some of them with disks, some of those disks with planets. The explosion that takes the middle star out of our sky is the same event that seeds the next set of worlds. It is not a loss with a silver lining. It is the mechanism. It is precisely how everything, including the rock you are lying on and the calcium in your bones and the iron in your blood, came to exist at all. Come back from that now. It has not happened. Tonight, the belt still has 3 stars, and if you go outside you can check, and the check is free and takes 11 seconds and works from anywhere on Earth. I have gestured twice now at the idea that these stars are manufacturing the material of future worlds, and it deserves its own proper stretch, because it is the single most direct connection between those 3 points of light and the body lying in your bed. Start at the beginning, which was remarkably plain. When the universe cooled enough for atoms to exist, roughly 400,000 years after it began, the inventory was almost entirely hydrogen and helium, with a trace of lithium. That is it. That is the whole periodic table for the first few 100 million years. No carbon, no oxygen, no nitrogen, no calcium, no iron, no phosphorus. None of the things any living thing is built from, and none of the things a rocky planet is built from either. A universe of the 2 lightest gases and nothing else. Every other element that exists was manufactured afterward inside stars. The lighter ones come from ordinary fusion, the process we described earlier, working its way up from hydrogen to helium to carbon to oxygen and onward. A star is a factory that takes the simplest material in the universe and welds it into heavier things, and the heavier things accumulate in its core over its lifetime. But manufacture is only half the problem. The elements are useless, locked inside a star. They have to get out. And there are essentially 2 ways that happens. Modest stars like our Sun, at the end of their lives, swell and shed their outer layers relatively gently, drifting them off into space over hundreds of thousands of years. And massive stars do it violently, in the event we have been discussing all night, blowing their entire accumulated inventory outward at a substantial fraction of the speed of light, and in the process of the explosion itself creating a great many of the heaviest elements that ordinary fusion cannot reach. So the picture is this. The universe began with two elements. Stars made the rest. Dying stars distributed them. The gas that was left over got mixed and enriched, and eventually recollapsed into new stars, which were born with all the heavy material their predecessors had made. And around some of those stars, for the first time, there was enough heavy material to build something solid. Rocky planets are only possible because earlier stars died. There is no other source for the material. Everything you can pick up and hold was made in a stellar core or a stellar explosion and then scattered. And this is where it becomes personal in a way I think is genuinely worth carrying to sleep. Take a survey of your own body. The oxygen, which is the largest part of you by mass, was made in the cores of massive stars and released when they exploded. The carbon that structures every molecule you are built from came from stars, much of it from the gentler deaths of medium-sized ones. The nitrogen in every protein, the calcium in your bones and teeth, which came specifically from massive star explosions, the iron in your blood, in the hemoglobin carrying oxygen around your body right now as you lie there, made in the final desperate stages of a star's life and thrown outward in the collapse. Not made of the same kind of material, made of the actual material. Those atoms were inside a star, every single one of them. Which means the relationship between you and the three stars in the belt is not metaphorical and not distant. It is a supply chain. Stars exactly like Alnilam, doing exactly what Alnilam is doing now, at some point in the past, in some other part of this galaxy, manufactured and then scattered the specific atoms that were later swept into the cloud that made our sun and our planet, and eventually you. You are downstream of an event just like the one that is coming to the middle star of Orion's belt, and it runs forward too. The atoms in Alnilam right now, the ones it is throwing off at 1,000,000 miles an hour, and the far larger inventory it will scatter when it explodes, will spend a few million years mixing into the gas of that complex, and some of them will end up in stars that do not exist yet, and some of those will have planets, and on some vanishingly small number of those planets there may eventually be something capable of looking up. So when you go outside and find those three stars, you are looking at the same process that assembled you, running in a different place, at a different point in its cycle. Behind you, it made your bones. Ahead of it, it will make somebody else's. There is a well-worn phrase about being made of star stuff, and it has been repeated so often that it has gone smooth and stopped meaning anything. So let me put the unworn version. The iron in the blood moving through your hands right now was made in the last hours of the life of a star that died before the sun existed, and it has been in you since you were built, and it will still exist long after you and this planet are gone, and it will probably be in something else. You are a temporary arrangement of very old material, and so is everything you love. And so are those 3 lights in the belt. Which brings us to the last thing the belt is hiding, and it is the one I find hardest to hold in my head because it undoes something that feels permanent. Orion is temporary, not the stars, though they are too. The shape. Every star you can see is moving. They orbit the center of the galaxy, all of them, at enormous speeds and in slightly different directions, and they drift relative to one another continuously. Astronomers call this proper motion the slow crawl of a star across the sky over years and centuries, and it is measurable for essentially everything nearby. The reason the constellations look fixed is not that they are fixed. It is that a human lifetime is far too short to notice, and even recorded history is barely long enough. But extend the time scale and the patterns come apart. Every constellation is a temporary arrangement, a snapshot of a crowd that is still walking. Run the sky forward 100,000 years and none of the familiar shapes survive recognizably. The Big Dipper distorts into something unrecognizable, its handle bending because 5 of its stars are moving together and 2 are not. Orion, likewise, will smear and stretch and eventually dissolve. So, the pattern that every human culture in history has looked at and named, that is on the pyramids and in Aboriginal songlines and Chinese star charts, that has been a fixed reference for navigation and agriculture and myth for as long as there have been people, is a temporary alignment of objects with nothing to do with each other, seen from a moving platform, during a brief window in which it happens to look like a man with a belt. And we are inside that window. That is the part I keep turning over. Human beings and the recognizable shape of Orion overlap. Our species arrived while the pattern was assembled, and our species will very likely be gone or unrecognizably changed before it comes apart. Nobody designed that coincidence and nothing depends on it. But every myth ever told about those stars exists because a walking crowd of suns happened to line up during the few 100,000 years that there were people underneath to look. There is a further layer too, which is that even the window is shorter than the stars themselves. Remember that Alnilam is expected to end within roughly 1 million years, so the belt will not survive long enough to be dissolved gently by proper motion. It will be broken by an explosion first. The shape has an expiry date and the mechanism is already decided, none of which changes what happens if you go outside tonight. And I want to bring it back to that before we close, because the whole point of this particular subject is that it is available to you. Here is what to do, and it costs nothing. Wait for a clear night. In the northern hemisphere winter, Orion is up in the evening in the south. In the southern hemisphere he is up too, standing on his head, which is worth knowing if you have only ever seen him one way up. Get away from direct lights if you can, even just into a shadow, and give your eyes 20 minutes to adapt, which is longer than most people are willing to wait and makes an enormous difference. Find the 3 stars. They will find you. Honestly, they always do. Then look at them one at a time, which almost nobody does, because the belt is so strongly a single object in the mind that the individual stars get skipped. Look at the left one, Alnilam, and know that it is 3 suns, not 1. Look at the right one, Mintaka, and know it is several more, and that it is sitting on the celestial equator, marking east and west for anyone who needs it. Then look at the middle one and stay there a while. That is Alnilam, 40 times the mass of our sun, something like 400,000 times its light, 4.5 million years old, which means it ignited while our ancestors were learning to walk upright on the African savanna, and it will be gone before anything much comes of us. It is throwing its own substance into space at 1,000,000 miles an hour as you watch. Its light left in the 9th century, and it is, at this moment, one of the most luminous objects any human being can see without instruments, sitting in the middle of the most familiar pattern in the sky, entirely unremarked by almost everybody who looks at it. Then let your eye drop to the sword below and find the fuzzy one, and know that the fuzziness is real, that you are seeing an object rather than a point, and that inside it hundreds of new solar systems are condensing out of the dark right now, and that ours was one of those once. And then, when you have looked at all of it properly, notice the last thing, which is the point of the whole night. You are seeing a line that does not exist, made of stars that are not neighbors, in a shape that will not last, lit by light that is 12 centuries old, and every part of that is true simultaneously, and it is still one of the most beautiful things you can see from your own doorstep, with no equipment and no expertise and no permission. Since we have spent the night on how human beings have read those 3 stars, it is worth going properly into what they actually made of them, because the record is richer than the quick tour I gave at the start, and one part of it needs handling carefully. Begin with ancient Egypt, because it is the association most people have heard of. Orion was identified with Sa, a figure closely tied to Osiris, god of death and rebirth and ruler of the underworld. That much is solid and well documented in the funerary texts. Egyptian religion was deeply concerned with the circumpolar and the seasonal, with the annual flooding of the Nile and the heliacal rising of Sirius, and Orion sat in that sky as a major figure. Now you will have encountered a further claim, because it has been enormously popular for decades, which holds that the 3 great pyramids at Giza were deliberately laid out to mirror the 3 stars of Orion's belt. It is a beautiful idea, and it turns up constantly. I want to be straight with you about it. The mainstream position among Egyptologists and astronomers is that this does not hold up well. The objections are specific rather than dismissive. The match between the pyramid layout and the belt is not especially close, and getting it to work requires choosing a particular orientation and being generous about the fit. The Egyptians left no text describing such an intention, despite leaving a great deal of text about their religious purposes. And the pyramids were built by different pharaohs across decades, which makes a single unified design harder to argue for. There is also the awkward fact that the proposal has usually been packaged with claims about dating the layout to many thousands of years earlier than the archaeology supports. None of which means the Egyptians did not care about Orion. They plainly did, enormously. There are shafts in the Great Pyramid whose alignments have been argued to point toward Orion's belt, and that discussion is genuinely live and interesting. The careful version is that Orion mattered deeply to Egyptian cosmology and that the specific ground plan claim is not supported. I would rather give you that than the exciting version, because the exciting version is the sort of thing a viewer looks up afterward and finds has been picked apart, and then wonders what else was overstated. Elsewhere, the readings are wonderfully varied. In Mesoamerica, Maya tradition identified a triangle of stars in this region as the three hearthstones of creation. The stones set around a cosmic fire at the beginning of the world, and the fuzzy patch we now know as the Orion Nebula was red as the smoke or the embers of that fire, which is a remarkable piece of intuition, because that fuzzy patch really is where new things are being made, and the people who called it the smoke of the first fire had no way of knowing they were pointing at a stellar nursery. In several Aboriginal Australian traditions, the belt stars are young men, often hunters or dancers, and the nearby Pleiades are a group of sisters, and the story is one of pursuit across the sky. Versions of that same structure, hunter and sisters, appear in Greek myth as well, entirely independently, which has long fascinated people who study such things. It may be coincidence, since a bright group of stars near a bright cluster invites a pursuit story anywhere. Some researchers have argued for something older and shared. Either way, the same two objects have been paired into the same kind of narrative by people separated by the entire width of the world. In Chinese astronomy, the region formed part of a lunar mansion called Shen, one of the divisions used to track the moon's monthly progress through the sky. Embedded in a system of celestial administration that mapped the heavens as a bureaucracy mirroring the empire below. And in the northern folk traditions of Europe, the belt picked up plain working names, a rake, a staff, a set of scales, the kinds of names given by people who used the sky as a calendar and a clock rather than a theology. What strikes me across all of it is not the differences, but the consistency of the impulse. Every group looked at three evenly spaced points and could not leave them alone. The specific meanings vary completely: hunters and gods and hearthstones and farm tools. And the underlying move is identical everywhere. Three things in a row must be a thing, which, as we now know, is our own perception constructing a relationship that space does not contain. And yet the relationship turned out to be real anyway, in the form of a shared birth that nobody could have suspected. Human pattern recognition, applied to a coincidence, arrived at a conclusion that modern astronomy has partly vindicated. That is either a lovely accident or a hint about why our pattern hunger was worth having, and I am honestly not sure which. Now, as we finally come to the end of tonight, let us gather it all up, because I think this particular subject changes something small and permanent about going outside, And I would like that change to survive the night. We started with the most familiar thing in the sky. 3 stars in a row that everybody knows, that nobody thinks about, that every culture in human history has noticed independently and built stories around. And we pulled on the thread. The line is not a line. Those 3 stars stand at different depths, separated by distances that dwarf the spacing they appear to have, and the neat evenness of the row exists only from here, only now, only because our solar system happens to be sitting in the one place from which they align. But they are family, which is the better truth. Born from one cloud in one event a few million years ago and scattered since. The ancient astronomers who decided those stars belong together were right about the relationship and wrong about the geometry, which is a very forgivable way to be wrong. They are not modest stars. The left one is 3 suns, the right one is several more, and the middle one is a 40 solar mass monster pouring out something like 400,000 times the light of our sun, so young it is 1,000th of our sun's age, shedding its own substance into space at 1,000,000 miles an hour, and so close to the end of its life that within roughly 1,000,000 years it will swell, redden past Betelgeuse, and detonate. Beneath them hangs a nursery where solar systems are condensing tonight, and beside them a horse that is only a horse from here, and behind all of it an enormous dark cloud that has been making and killing stars in waves for 20 million years, ringed by the scar of an older explosion. And the whole arrangement is temporary. The stars are drifting, the shape is dissolving, and the middle one has an expiry date that will break the belt long before the drift does. We are inside a window in which the pattern exists, and there are people underneath to see it, and both ends of that window are moving. So here is tonight's cascade, the part to take down with you. The line is not real, and the family is. The shape is temporary, and the light is medieval. The middle star is one of the most luminous things any human can see, and almost nobody who looks at it knows that. The nursery below it is making worlds right now, and ours was made in one just like it. The iron in your blood came out of a star doing what that star is about to do. And every part of that is true of a thing you can walk outside and find in 11 seconds tonight for free, without equipment or expertise, from wherever you happen to be standing on this planet. That is the reason this one is worth a night. Most of what we talk about on these evenings is permanently out of reach, and beautiful for exactly that reason. This one is overhead. You have already seen it. You saw it before you knew any of this, and you will see it again knowing all of it, and it will look precisely the same and be completely different. Thank you for spending this night with the 3 most familiar stars in the sky. If sleep has been waiting at the edge of the room, let it come in now. Nothing up there needs watching, and the belt has been holding its shape without any help from us for the whole of human history, and will manage a few hours more. And when you next find yourself outside in the dark and you catch that line of 3 without looking for it, the way everyone always does, you might remember what you are actually seeing. Not a belt, not a row, 3 enormous, brief, doomed suns at 3 different distances, born together and drifting apart, sending you light that left before your language existed, arranged into a shape that only exists from the ground you are standing on, and only for now. It is the most ordinary sight in the night sky. It is also, once you know what it is, one of the strangest. Sleep well, under 3 stars that were never in a line. Good night.